Hi everyone, I am Mr. Gababe Jr. and this video I presenting my activity for web application system architecture and network design. My presentation has two parts. First, I explain the web application system architecture of my Laravel and Next project, and second, I discuss my network architecture design for a dual-floor building. As you can see on the screen, as shown in this diagram, this is how my Laravel and Next.js web application works from end to end. On the left, we have the user who interacts with the system through a web browser when the user performs an action like logging in or viewing data. The browser sends HTTP requests to the Laravel API server. The Laravel API server is responsible for handling this request. It processes logic, retrieve information, and communicate with the database, shown here in blue. Laravel sends SQL queries to the database, and when it gets a result, it returns them as JSON responses to the Nuxt.js frontend. The Nuxt frontend then takes those responses and displays them visually to the user, creating a smooth and dynamic experience. On the right side, you can see the deployment section, where the entire application can be hosted on a virtual server, like for example inside VirtualBox or a local server environment. This setup shows the complete flow of data from user request to the Laravel backend to the database and back-to-back frontend. Now let's move on to part 2, which is my network architecture design. As you can see in my diagram, this setup represents a two-floor building, and each floor has 10 PC connected to the network. Starting from the top, we have the internet connection, which is linked to the router. The router serves as the main gateway that connects the internal network to the internet. From the router, a switch is connected. The switch distributes the network connection to both floors and also to the access point, which provide wireless connectivity for Wi-Fi users within the building. On the left side, we have floor 1, which uses a subnet 192.168.10.0 to 24. Each of 10 pieces on the floor 1 has a unique IP address within the range, such as 192.168.10.1 and 192.168.10.2, and lastly the 192.168.10.3, and so on. And this setup allows all devices on floor 1 to communicate with each other within the same subnet. On the right side, we have floor 2, which uses a different subnet 192.168.0.0 to 24. The 10 PC on this floor are assigned IP addresses such as 192.168.20.1 and 192.168.20.2, and lastly the 192.168.20.3, continuing in sequence. Okay, so both floors are connected to the same switch, which then links back to the main router. Okay, so this allows devices on both subnets to access the internet while keeping the traffic of each floor separated and organized. And then so the access point on the right side also connects to the switch, enabling wireless devices like laptops or smartphones to join the network without using cables. This design follows the principle of subnetting, which each floor has its own subnet for better network management and security and efficiency. The use of standard network devices such as Cisco routers and switches makes the setup more reliable, scalable, and ideal for small office or school building environments. Overall, this network design ensures that both floors are properly connected to the same main network, have stable internet access, and are organized through separate subnets to maintain smooth communication and data flow across the entire system. And that's all. Thank you for listening. Keep safe and God bless.